Hello, everyone. Welcome to our lesson on data representation. This is our first topic in ASA level statistics. Today, we'll be looking at specifically averages and spread. The aim of our lesson today is to explore the concepts of averages and then measures of spread. We will, at the end of the lesson, we should be able to write, formulas, substitute correctly into formulas, and then use formulas to solve problems. Right, so let's get started. In statistics, we have two different sets of data. We have the single data, and then we have what we call the group data. So for single data, what we are talking about is a data given in individually, okay, or individual sets of observations. For example, you can talk about the ages of students in a class, okay, and then they will list all the ages. Maybe the first person is 2 years, the second person is 4 years, followed by maybe 5 years, okay. So, set of data given. Now, when we talk about group data, it means that we are going to check maybe the ages of the people, but within certain intervals. Okay, so maybe we are going to record the ages of people who are from 2 to 10 years, then from 11 to maybe 20 years. Okay, then maybe let me clean this one. Then we will check the ages of people maybe from 21 to maybe 30 years. Okay, and then given this interval that we are going to use, maybe we get 3 people here, we get 5 people here, then finally maybe 7 people here. Okay, so that is the group data we are talking about. This is the observation that has been grouped. Basically, that is it. Okay, so but in this lesson, I'm going to focus mainly on the single data values. Okay, I just wanted to talk about group data so that you know that it is out there. Okay, in our subsequent lesson, we will talk about group data. Well, so under single data, we have the mean to be given as sigma x over n. What this actually means is that you are going to sum all the observations that you have, then you divide it by the number of observations. I have questions here to help us understand how that will be done. Then for variance has three formulae. Variance is actually given by the sum of all the x values minus the mean. Okay, then we square them divided by n. Or you can say that when you actually expand what you have here, this is what you get. Okay, which is the second formula for the variance. So it's the sigma x squared over n minus the mean, okay, because this is the mean, okay, sigma x over n all squared. So it is the sum of x squared values, okay, divided by n minus the mean squared. That's all. Now, if you don't want to write it this way, you can write it in that way. That is also fine. The only difference between what we have here and what is here is the mean. This, we wrote the formula for mean, and this is just the symbol for mean. So nothing changes. Now, standard deviation for single data values. For standard deviation, it is the square root of the variance. So if you look at this formula here, it is what we have there. Okay, just take the square root of the variance and then you are good to go. Let me quickly tell you about the group data, then we start to solve questions about on this particular topic, averages and then spread. For group data, this is the mean, where the x is the class midpoint and then the f there is the frequency. And the variance is also given as this. Then finally, standard deviation is the square root of the variance. So like I said, this lesson is mainly on the, how do I call it, single data values. So let's get started. Okay, so we have our first question here. This is actually a past question that I took from the year 2008. Okay, it says Rachel measured the length in millimeters of some of the leaves on a tree. Her results are recorded below. So she got from 32 millimeters to 45 millimeters. And our job is to find the mean and then we should also find the standard deviation of the height of these leaves. So now, how do we go about it? Well, we are told to find the mean. We know that the mean is given as x bar, and the formula is we should sum all the x values up and then divide by the number of observations. So that is what we are going to do. Now, these observations given are the x values, okay? The x is the observation. So we are going to add these up. So we have 32 plus 35 plus 45 plus 37 plus 38 plus 44 plus 33 plus 39 plus 36 plus 45. Okay. Then the next thing that we do is that we are going to divide. Okay, so let's divide. We are going to divide by the number of observations. Okay, and the number of observations are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so we are going to divide by 10. Now, when you put this on your calculator, you should get 38.4 millimeters. So always we give our answers to 3 significant figures, unless the question tells you otherwise. In AS and A-level statistics, you give your answer to 3 significant figures. Okay? All right. Now, the next bit of the question said that we should look for the standard deviation. Well, the standard deviation is, you can say SD is equal to the formula, or you can use the symbol for standard deviation, which is this. Now, it is the square root of the variance. And the standard deviation is given as sigma x squared over n divided by the mean. Okay, the mean, sorry, minus the mean squared, not divided by. Okay, so what will actually happen here is that we will take all the x values, okay, and then square them. All right, so let's start. Let me first take the square root of this thing. Okay, so we have 32 squared plus 35 squared plus 45 squared plus 37 squared plus 38 squared plus 44 squared plus 33 squared plus 39 squared plus 36 squared plus 45 squared. Okay, so that is this bit of it. It says we should square all the x values and then we should sum them up, and that is what we have done. After that, we should divide by what? By n. Okay, so let's go and divide by n. So this divided by n. Now we know n is what? Is 10, right? Okay, then the formula goes on to say we should subtract the mean. All right, but what did we get for the mean? We got 38.4. all right, so let's go and do that. So we have minus 38.4 squared. Okay, now what this means is that we are going to get if I don't know, maybe all this will not go on your calculator, so let me break it down a little bit. So that means when we square and sum these up, we should get 14954, okay, over 10, then minus our mean square. Now we can put everything on a calculator, and then that would mean that our answer should be 4.57 millimeters. So this is to 3 significant figures. All right, so this is how we solve it. Now let's look at this question. Now I want you to take a moment, pause the video at this point, solve it. After that, you compare your answers with what we will get on this channel. Okay, if it is correct, then bravo. If it is wrong, you know where you went wrong. Okay, all right, so I hope you have paused the video and I hope you have solved it. So now let's solve it together. We are to find the mean and then the standard deviation. So let's start from the mean. We know that the mean is given as sigma x over n. Now let's look for the sigma x, and that will mean that we will add all the observations we have. I think that is 11, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Good. So let's add them up. So we have 48.3 plus 55.2 plus 59.9 plus 67.7 plus 60.5 plus 75.6 plus 62.5 plus 57.4 plus 53.4 plus 49.2 plus 64.1. Okay, everything here we are going to divide it by 11. All right, so that means that we have from our calculator we have 653.8 over 11, and this should give us 59.4, and this is correct 3 significant figures. All right, so that is the mean. For the standard deviation, like I said, this is the symbol. I like to write down the formula before I solve, and the reason is that it helps me to know what I'm doing. So this is the formula for the standard deviation. Now let me complete it. Okay, we don't need this bit of it. Let me exclude. Okay, so it's good. All right, so we need our sum of x values. We are going to sum the squares of these values. Okay, so let me do that here. That means we have 48.3 squared plus 55.2 square plus 59.9 square plus 67.7 square plus 60.5 square plus 75.6 square plus 62.5 square plus we got to what, 62.5, okay, plus 57.4 square plus 57.4 again is double, right? 54.4 squared plus 49.2 square plus 64.41 squared. Okay, now this, according to my calculator, gives me 39508.86. Okay, I could be wrong. I mean, you should verify that. All right, I think that is all that we need. The rest is easy to work with. Okay, so the standard deviation is the square root of, now we know that this is what we have here. So now let's solve it. So it means we have 39508.86 divided by the number of observations is 11 minus the mean. Now I don't want to use 59, this 59.4, because this is an approximated value, so I'm going to use this mean in my calculation, and that is what you should always do. Don't use approximated values in the next solution. Always use the entire thing. Okay, so let's do that. Now that means we have the mean square, right? So that's 653.8 over 11 all squared. Let me increase this line. Okay, now you put everything on your calculator, and then that should give you 7.68. That is correct to 3 significant figures. So I hope you got these answers. You got your mean to be 59.4, and then your standard deviation to be 7.68. Well, sometimes in your examination, in fact, these two questions that we've solved are past questions. Okay, all right. So sometimes in your examinations, they would give you a question that is not in the how do I call it? They have not given you data like this data that we have here. Okay, or this data. No, they will not. They rather sum them up for you. For example, they'll give you the totals. Okay, like they'll give you the sigma x, and then they will give you the sigma x squared. They will rather give it to you. When they do that, I mean, that is great. That is great. You don't have to go through adding all these things up. Me, I don't like doing it. So when they give me the totals, I'm really happy. So we are going to solve a question that has the totals. This question, this is it. This is actually 2012 question. You can verify this. You know the course code already, 9709 /606 /May/June /2012. This is the question one from that year. You can verify that out. So they gave us a question like this: the ages x years of 150 cars are summarized by we have, this is the sigma x, and then this is the sigma x squared, and then our job is to find something like that. Now the first thing that I advise my students to do is to write down the details from the question. What are these details? The details are, we know sigma x is 645. We also know that sigma x squared is 88,287.5, and then we are told to find sigma x minus the x bar squared. Okay, now whenever you are given this, what comes to mind? Yes, variance. Okay, because this actually comes from the variance formula. Variance is giving us the sigma x minus x bar all squared over n. So this is the variance formula. That is why the numerator alone, when you are given something like this, it should give you a clue that no, you are working with variance. So quote the variance formula. All right. Now, when you expand this and you simplify, this same formula can give you another formula that is really useful. Okay. And this is what I have quoted here. Now, the reason why you need to expand to simplify to get the second bit of this formula is that the question gave you sigma x, which is here, and it gave you x squared, which is here. All right, at least that I forget. Let's see. Okay, we were given 150 cars, right? So that is n. So let me write that down. N is 150. Okay, so now if we want this, okay, it means we should multiply through by n, isn't it? Good. So now that gives us, so sigma x minus x bar square will give us n, and then we have everything like this, nicely done. All right. So now all that we need to do is to do substitution, and then we have solved the question. N is 150. Okay. And then x squared, sigma x squared is 8287.5. Then we divide it by n, which is 150, minus sigma x, that is 645, divided by n, 150, we square. And then this is the job of the calculator. That is why you bought it. So using the calculator to solve this, you should get 5514. So this is the value for the sigma x minus x bar all squared. And then you are good to go. All right. So I have a question here. I want you to pause it. This is the question. I want you to pause it. Pause the video, solve it. After that, unpause the video, compare answers, and see if you are right. If not, I mean, you have the opportunity to correct yourself. Well, so I hope you have paused the video at this point and that you are ready to go. So let's see. We are supposed to find the mean. So that is the I. Well, the mean is giving us sigma x over n. Okay, and sigma x is 584 divided by n, which is 100, and this should give you 5.84. II says the variance, which some books will call it var x, or others will call it sigma square. I mean, it's fine, whichever one you write. So that is given by this formula, and I hope by now you have memorized it. Okay, so from the question, we were given that sigma x squared is 23781 over n, and then the n is 100 minus sigma x, that is 584 over n, 100 all squared. I know you want to say, but we can just write this 10 squared. I know, but sometimes it is not the best, because maybe this you have is an approximated, okay, but this is not approximate. This is actually the answer, so you could have used it. Okay, so this on our calculator, let me do that real quick and come. So that should give us 203.7044, and then to three significant figures will give us 204. Okay, three significant figures. Then finally, we are to find the standard deviation. That is I. Now, the standard deviation given by this symbol is the square root of your variance. Okay, so let's just write square root of 203.7044. All right, and now with the help of the calculator, you should get 14.3. Okay, and this is correct to three significant figures. So I hope you got these answers. You got your mean to be 5.84. You got your variance to be 204. That's correct to three significant figures. And then finally, you got your standard deviation to be 14.3. All right. So in our next lesson, I'm going to talk about combined data. What combined data means is, okay, what if you are given a set of data on men, and then a set of data on females, or on women, and then you are told to combine, put those two data together and find the mean or the standard deviation from those observations. Okay, so that is what we are going to talk about in our next lesson. So look forward to that video.